Good afternoon, distinguished participants, colleagues, and organizers. My name is Ramesh Paudyal from Nepal. My research area is uh, data security. In respect to the researcher motivated by the enhanced trustworthy digital infrastructure, particularly in the context of digital public infrastructure, uh, further coming challenges of post-quantum computing. The research background and problem statement are cloud computing has become a indispensable model to delivering computing resources such as storage, database, and processing power on demand basis. However, this advancement has also raised significant data governance and security challenges. Sensitive information is often transferred without appropriate classifications. Traditional uniform security mechanism increases the overhead while failing to adopt the data sensitivity levels. Moreover, emerging quantum technology poses a substantial futures threat to current cryptographic system. These limitations highlights to necessary for the data-centric and adaptive data governance model for cloud data governance. The research objectives are automatically classifying data into uh, the different categories like public, sensitive, and confidential. Applying the security mechanism, including um, cryptographic algorithm like AES and ECC, ensuring the readiness for integration with post-quantum cryptographic techniques, and strengthening the security framework required for digital public infrastructure. The methodology used in this research are in six sequential phases. First one is data pre-processing. Data is collected from the different government agencies of the Nepal that is categorized into public, sensitive, and confidential classes. Input parameters are divided from cloud divided from cloud governance security dimensions, that is security, that is also called security triad, CIA triad: confidentiality, integrity, and availability. The fuzzy logic framework that is implemented using the trapezoidal membership function for the input parameters and triangular function for the output. Rule-based construction using if-then rules processing through the Mamdani inference engines. Defuzzifications is used for the mean of maxima methods to determine the crisp sensitivity outcomes of this our subjectives leveling of um, um, the security parameter like CIA on the basis of organization requirement and sensitivity level of the data. The security assignment mechanism is public data is not needed more security. The system is automatically assigned nominal security mechanism. Sensitive data required more, confidential data also needed more security. So the system is automatically assigned the required required the security algorithm based on the sensitivity level of the data. Experimental setup is conducted within the AWS EC2 environment. Data files ranges from 0.25 GB to 2 GB were proceed. Both secured and non-secure data mobility scenario were analyzed to evaluate classification efficiency, response time, delay, and throughput. The key finding of this project of this research are classification efficiency. response and delay time and throughput of the overall system using the data set. The significance of this research is provided on the basis of sensitivity based security classification and management in cloud computing environment for the for the data governance. It enhances the trustworthy of digital public infrastructure by enabling efficient and secure data sharing mechanism. It ensures the future readiness by supporting a transition towards post-quantum cryptography, which is critical in safeguarding against further coming quantum threats. In conclusion, the fuzzy rule-based classification system proposed in this study demonstrate the feasibility of integrating automated classification, security optimization, and secure data mobility within the cloud environment uh, in one framework. These all tax are tax are completed by this system. In advance, uh, the paradigm of cloud data governance by enabling selective encryption, reducing overhead, and supporting digital public infrastructure framework. In future works will involve scaling approaches to the big data ecosystem and integrating adaptive post-quantum computing algorithm to strengthen the resilience against the quantum enabled cyber attack. Thank you.